So to find standard notation, it's basically drawing out the equation, so making it longer, or instead of condensing it, like expanding it. So when you have a exponent, you know it's 5 times whatever by itself, how many times the exponent is. And so you do 5 times 5 times 5. That's standard notation, and then it would equal 125. That's how I got this problem. And then for B, it's the same thing up here, but you just do it with 12. So and that's how I got for B. And then for 3, it's just the same thing as all the other ones, but just B. Equals, I got 2,187.
Okay, thumbs up or thumbs down? All right. The one little added thing I'd like to add to say for this is we have some vocabulary words that we can talk about really quickly. Sawyer actually used the correct words whether she realized it or not. But this form right here, 5 to the third, is called exponential form. It's called exponential form because you have a base, and this is the base, in this case 5, taken to an exponent, 3. So that's exponential form. When Sawyer wrote it out as 5 times 5 times 5, that is actually called expanded form. And she actually used those correct words. Did you know that beforehand? Sort of. Okay, perfect. And then finally, this 125 is standard form because that is the form that we normally use when talking about numbers. So do I have any volunteers for question D? Volunteers for question D.
Okay, so for D, it tells us to add the equation it gives us. Because it has variables in it, we do not know what D is, so we cannot add it fully. So we can add what's the same. And then, so 40 plus 8D equals 12D. And then we can also do D to the power of 2 and negative 3D to the power of 2. So if you add those, you get negative 2D. And then after this, all we have left is negative 8 plus negative 9, and then that's negative 17.
All right, so thumbs up, thumbs down? Okay. Now I'm going to again add a little bit of explanation here about math grammar because I don't know what could be more fun than math grammar. It is typically good math grammar to put the term with the largest exponent first. So which term has the largest exponent here? Negative 2d to the second. So typically the answer to this problem would be written as negative 2d squared. Is this positive or negative? Plus positive 12d, and then you'd have your minus 17. Are there questions for this problem? Yes, ma'am.
Can you write it that other way, or do you want us to write it?
The answer you really want is this. This would be marked wrong. Okay. Would it be marked wrong today? No, because you didn't know anything about it, right? But in the future, this is called ordering in terms of degree. Degree is the exponent. So this is a second degree equation because the exponent is 2, second degree. Make sense? Yes, sir.
So you always put the biggest thing first?
The largest exponent first. There's just like English, the term with the largest exponent first. Now, if you have two different variables with exponents, then you go in alphabetical order. And I mean, so there's some nuance, but that's pretty much it. All right.